Let's now implement these two methods together. One of them is all multiples of 5. So given an integer array, we want to see if all the elements in the array are multiples of 5, i.e. modulo 5 equals 0. Okay, and a symmetric problem is we want to see, given also an integer array, we want to see if at least one of the elements is a multiple of 5. So these two are very typical problems to say, given a collection of data, you want to see either all the data in the collection satisfy a certain property, for example, multiples of 5. That's one category of problem, to see all the elements satisfy a property, or at least one element satisfy the property. So for those of you who learned about a little bit logic in 1019, so this is more like a universal quantification. But if you haven't, that's okay. I'm just drawing some connection for those of you who took 1019. So all multiples of 5 is like a universal quantification problem. We want to see if every element in a collection satisfies a certain property. And this at least one multiple of 5 is more like another category of problem. For that one, it's more like existential quantification problem. We want to see if there exist any elements in the collection that satisfy a certain property. Okay, we're going to handle these together because the way we handle them, it will be very similar. It's only the critical logical operator that will be a little bit different. And also the initial value for empty collection will also be different. Okay, notice one thing. Over here, if you look at the description of the method, we did not say you can assume that the array is not empty. So that means the array can be empty, positive. Okay, so now the question would be, what about, let's handle these cases first. What about given empty array, are all the given an empty array, are all the elements in the empty array multiples of 5, true or false? That's the base case. Okay. Similarly, given an empty array, is there at least one element in the empty array that is multiple of 5? Okay. That's these are the two questions we want to answer. Okay. Let's have a look at some examples, and then we'll figure out the base cases on the iPad, and then we can program. Okay. Let's go to iPad over here. So now, let's have a look at IA5. Oh, by the way, if you go to your utilities tester, there's one new array I added for illustration. So you can just put it in your utilities tester. You can also put IA5B. Okay? So just put 4, 11, 14, 25, and 19. So there's a reason I put this extra input for you for illustration, but we'll get there. Okay? And also, you can add over here U dot all multiples of 5, IA5B, and also U dot at least one multiple of 5, IA1B. That's IA5B. That's something you can add. Okay, let's go back here. And now let's think about, for this case over here, if I got IA5 over here, are they all the multiples of 5? 5 is, and 10 is, 15 is, and 19 is not. And then 25 is. So now in this case, as long as we can find one witness of violation of, actually, let me make it a little bit easier to read. Witness of property violation. In this case, 19. So we say that 19 is the witness for the violation of the property. In this case, the property that we are checking is multiples of 5. So 19 is not a multiple of 5 because 19 modulo 5 is not equal to 0, right? So if you have 19 modulo 5, in that case, it's actually equal to just 4, which is not 5, right? So that's not a multiple of 5. So we say that it's a witness. So that's a word you should really learn for this course, witness. Okay, it's a witness of the property violation. So now, so that means as long as you can find out a witness that tells you the property can be violated by at least one element in the array, that means the all over here will actually tell you that it's not the case that all the elements satisfy the property, because you can find at least one violation witness. Okay, that means in conclusion, this should be false. Okay, it is not the case that all the elements in the array are multiples of 5 because you can find out the witness, which is 19. Okay, hopefully the logic is clear to you. Now, given this logic, let's go one step further. What about empty array? Let's say we got just empty array. So let's say empty array. I just say EA, for example, empty array. Remember, the way you can create an empty array would be you can either say integer empty array is assigned to like that, or you can say alternatively, you can say empty array is assigned to, square brackets over here for array notation. Okay, we can say is new array integer and then of size 0. Either way, okay, either that or that. Okay, so now what about empty array? When I say all the elements in the empty array, so EA is somehow pointing to just an empty array. It does point to somewhere in the memory of the array, but the array itself does not store anything. It's empty. So now, it's when we say all the elements in the empty arrays are multiples of 5, is it true or false? Okay. So now let's think about the same logic over here. As long as we can find out a witness in the empty array that can prove that the property can be violated, for example, like the case of IA5, we can find 19. If we can find out a witness in the empty array such that that particular witness violates the property being multiple of 5, then we can say it's false. Otherwise, we gotta say it's true. Okay, that's the logic. I'll write it down for you. Okay, that means as long as we can find a violation witness, violation witness in empty array, then it's false. Otherwise, if we cannot find out any violation witness to prove that it can be violated, then it should be false. Then it should be true. Otherwise, it should be true. Okay, so here are the two possible outcomes. Okay, so it can be either false or it can be true. So now the question is, can we find out any witness to prove that the property can be violated? Now think about what empty array is. Empty array simply means there is nothing there. So there's no way you can find out the witness that can prove that the property can be violated. So that means the property can never be violated by any of the elements. So the property should be true. Okay, so this is a little bit counterintuitive to you, possibly, but you should just follow the logic. So we'll say that whenever you're doing this kind of a for all property to say all the elements satisfying a property, you would say that it does not all the elements are satisfying the property if you can find out a violation witness. If you cannot find out the violation witness, that means all the elements satisfy the property. Okay, really think about the logic. Okay, so now that means in the case of the empty array, it should be true. Okay, this is a very important boundary case you should really know. Okay, and this is not just for the multiple of 5. As I said before, if I just give you another question here, let's say, are all the elements in the array an even number? Are all the elements in the array positive number, and etc.? So the empty array is always going to be of value true. Okay, so that's something to note. Okay, so now let's do a similar exercise for the other question over here. Let's do a similar exercise. So now what about this one over here? So now this one here, we're asking at least one multiple of 5. Okay, so now let's see this. So we have at least one. At least one of the elements is a multiple of 5. Let's see if that's really the case over here. Okay, over here, let's see. 4 is not a multiple of 5. 11 is not. 14 is not. 25 is. 19 is not. So do we have at least one? Yes. And the reason that we have is because we actually got a witness of property. We can say, so what's the antonym for violation? You can see property satisfaction. in which case we have 25. Okay, so again, we are trying to find out the weakness. Okay, in this case, I'll just put weakness. As long as I can find out the weakness that proves that the property can be satisfied, then that means overall there's at least one element that satisfy the property. In this case, multiples of 5. Okay, so now in this case, that means this result here should be true. Okay, you can see similar. You can see we just talked about different examples over here. For this particular case, we find out 19 being the violation weakness, and over here we're finding 25 being the satisfaction weakness. Okay, it's different kinds of weakness to actually see how the two kinds of problem can be solved. So now, what about empty array? Okay, similarly, if I have empty array EA pointing to some empty array, so now the question is, if you ask me if there's at least one element in the empty array that is multiple of 5, it's equivalent to asking the following question. Can we find at least one weakness of property satisfaction in the empty array? And the weakness satisfy the property, for example, 25, right? In this case, can we find out any weakness? The answer is no, we cannot, because empty array does not have any elements over there. So there's nothing we can find. So there's no way for us to prove that the property can be satisfied by one element. So the answer is, so now that means it should be false in this case. So in the case of the empty array, so if you ask any kind of question like at least one of the elements satisfy a certain property, the boundary case should be just false. Okay, should be just false. Okay, you can see that for empty array, the at least one kind of problem will be false, but for the all kind of problem, it will be true. Okay, you don't really have to memorize them, but you have to know how we actually derive the result. I'm really trying to explain to you logically. So it's really about finding the weakness for violation or finding the weakness for satisfaction. You should know when to find which. Let's now go back to Java. Now that we understood how the logic should work. Okay, so these are the two boundary cases you should really keep in mind. Okay, so now let's go back to our method over here. Let's now try to program that. Okay, so now what we will do is because we know that eventually we're going to return the Boolean result, which will be either true or false. In the we just have to declare some result. Let's say Boolean result is assigned to something. I'll put question mark just for now. Eventually return the result. Okay, and then we do something over here in the middle. Similarly, for at least one multiple of 5, I will also do something similar. Now, what should be the initial value for the result for this case, and what should be the initial value for this case? That's exactly why I talk about the base case for you. In the case of the all multiples of 5, like a universal problem. In this case, the base case should be true. Just starting with empty array, just starting with empty, nothing there has just been analyzed yet. And on the other hand, for the at least one kind of problem, it should be false. Okay, so that's what I would do. So that's why what I would do is I'll simply put true over here and false over here. So you can say for empty array, no violation weakness. For empty array, no satisfaction weakness. Okay, so now later after this, what should we do? Let's think about what we should do. Idea is very simple. Let's talk about the non-empty array. Let's say if you talk about this case over here. If you talk about this case over here, what we really want to do is to say the following. We want to say IA5 is a multiple of 5. That means IA5 modulo 5 equals 0. Also, we want to make sure it is n, because we want to say this is true and next one is also true. And also IA sorry, not IA5. What I meant to say was IA5 at position 0. IA5 at position 0, modulo 5 is equal to 0, and also IA5 at position 1, IA5 at position 1, modulo 5 is also equal to 0, and all the way to n%, IA5 at position 4. So 4 is just the last index. We want to make sure every element satisfies the property. Modulo 5 equals 0. But now the thing is, over here, I know exactly what 4 the last index should be in this particular case. But now, if you look at the method itself, it's only give you IA. So you only know that the 4 over here is really IA5.length minus 1. Okay, so that's why we should use a loop to actually accumulate the result together. And the way we're going to accumulate the result is by saying we're going to start with the true, as we said before. We're going to start with true, the result for the empty array, and then we are going to gradually to say, now, I'm going to say, I want to make sure every time if I calculate a new result to see if the current elements I'm looking at is multiple of 5, if it is whatever result it is, I'm going to accumulate that by saying, for example, I would say true. Okay, let's put true here, right? What I would say is, I would say true and over here. So I say true and this. So this is what I will calculate in the first iteration of the loop. So this will give me true, because true over here, and also 5 is also a multiple of 5. So that will give me true after the first iteration. And then I'm going to accumulate the results so far with the second elements. And the second element is IA5 at position 1, which is 10. 10 is a multiple of 5, so that will also be true. So true and true will give me still true. You can see I keep accumulating. As soon as I hit a result that is not true, the accumulation of conjunctions make sure at least one of the side is false. Overall, it's going to be false, right? Okay, so now you can see as soon as I hit this particular element over here, that one 19, so that will be IA5 at position 3. So you can see, okay, over here I can put, so of course you will have IA5 at position 3, modulo 5 equals 0 over here. You can see for that one there, it's going to be false. So now, for all we have accumulated so far is simply just true. Now true and false is going to give you false. That means overall it's going to be false. There's no way for you to go back to true. Okay, because once you, as long as one of the operands for the n%, remember we said before, for the n% to be true, both sides must be true. As long as one side is actually false, then we actually get to false. Okay, okay, let's do the conjunction first, and then we go back to disjunction. Okay, so what I would do is, the most naive way to do this, which is also correct, is by saying for integer I is assigned to 0, I is less than IA.length minus 1, I plus plus. Okay, so I'm going to accumulate a result. I'm going to say result is assigned to whatever result it is. Initially, result is simply just true because we assign it to be true. Okay, and then result n%, and then the current elements we have. Okay, I just put a parenthesis over here, and now we should really evaluate the property. So we would say IA at position I, the current one we're looking at, modulo 5 equals 0. You can see over here, the first iteration, I is going to be 0. The second iteration is going to be 1. And what about last iteration? In the last iteration, beg your pardon, I meant to say IA.length over here, not really minus 1. Okay, I could have said I is less than or equal to IA.length minus 1. That's equivalently correct. Okay, so now let me just go back to what I said before. Okay, I is less than IA.length. Okay, so now the last iteration there is going to be IA at position IA.length minus 1. In this case, it's going to be index 4. Okay, so now the most important thing to notice is we have some initial value being true, and then we keep accumulating to this true value, this value over here by the current result. Okay, now let's think about hypothetically. What if we actually put false over here? Would that be correct? If we put false over here, that means we started with over here false. So now what's gonna be the incorrect result? If I say false here, that means one of the sides of the conjunction is already false. So it doesn't really matter what this side over here is. Even if this side over here is true, true and false will give me false. And then it also doesn't matter what this result is, because true, even if true and false, will also give me false. That means once I initialize a false to be once I initialize the result to be false, that means the accumulation of conjunction will give me false no matter what. Okay, so that's why we should really put true over here. But logically speaking, you should really note it as the true, as I explained over here. Okay, you can see the code itself is not difficult, but the reason that I really want to explain to you is because there's a logical reason behind. Okay, so this is one way to do it. Okay, you can test it. I can tell you this version is correct. This is version 1. Okay, and let me do another one. Okay, so now if I just go for at least one multiple of 5, let's see what's gonna happen. Okay, so now for the same reason over here, for at least one multiple of 5, if I look at over here, at least one multiple of 5, you can see we started with false over here. That means we want to accumulate into false. Let's see exactly how that's going to occur. So we got IA 5B, that's the name of the array, and position 0 modulo 5 equals 0. And now we want to make sure at least one of them. So it's either this is a multiple of 5, or the second element is a multiple of 5. So 5B and also position 1 modulo 5 equals 0, or IA 5B at position 2 modulo 5 equals 0, and all the way to IA 5B at position 4 modulo 5 equals 0. Okay, that's what we have. So you can see now we're using logical disjunction as opposed to conjunction. Okay, so now how do we accumulate a result? We have result initially is simply just false, as we wrote over there. Okay, result is simply just false because empty array you cannot find any satisfaction witness. Okay, so now if I say initially it's going to be false, for the first iteration we're going to have result is assigned to result or this result over here. So let's say for the first iteration, this is going to be the first iteration. So false or something. Remember when we talk about disjunction, as long as one side is actually true, the overall result is true. The disjunction will be false if both sides are false. In this case, IA50 is talking about this element over here, so that will be false because it's not a multiple of 5. So we got false or false, which will give us false. Okay, and then so now in the second iteration we're gonna do the following. Let me use a different color. We're gonna say false or the second elements, and so now IA5B1 talk about this element over here. So 11 is also not a multiple of 5, so that'll be false. So we're gonna get false or false. That will also give us false. Okay, so now we still get false over here from the second iteration. What about the third iteration? For the third iteration, we keep going. Let me just do one more. For the third iteration, we're gonna have the following. We're gonna say false or IA5B at position 2, which talks about this element over here. 14 is not a multiple of 5. That means this particular result will be false, or false will give us false. Okay, so now that means from the third iteration we still get false. Let me just use one more color over here. So we'll still get false from that particular iteration. Okay, so now you can see that once we go to the fourth iteration over here, the fourth iteration will have 25 over here, right? 25 is indeed a multiple of 5. So let's just write it down. Okay, so now we do have IA 5B at position 3 modulo 5 equals 0. Of course, we got disjunction. Also, we got disjunction over here. Okay, so now in the fourth iteration, what we will calculate is like this. We'll say false or IA 5B at position 3, which is this element over here, is a multiple of 5. In that case, this result will be true, right? This will be true over here. This guy over here will be true. So now true or false will be true. So now as soon as we get into there, we actually get true. Okay, so now once we get as long as one side of the disjunction is true, the result will be true. That's how we accumulate the result. Okay. Okay, so you can see that you should really try to really walk through the code execution yourself as well to make sure you understand. Okay, so now what we have is we can say for integer I is assigned to 0, I is less than IA dot length, I plus plus, and then result is assigned to result or IA. You can see pretty much similar to how we did for all multiples of 5. We just use disjunction over here rather than conjunction. And also the initial value is false rather than true. Okay. Of course, you don't memorize this, but you should really understand the logical reasoning behind. I modulo 5 equals 0. Okay. So now, let's now think about a common mistake. I just want to mention that. So these two, you can execute the code and test it. I will leave that to you. So these two versions are correct. Now my question is, let me give you a wrong version. Okay, a wrong version. Version 1, correct. Okay, also this is also version 1, which is also correct. And that is correct, so I'm just going to copy and comment that out. I'll give you a second version which looks very similar, but I will ask you whether that's correct or not. Let me now get rid of the accumulation. I simply say this. Version 2, okay? Correct or not? Okay, similarly, let me also copy this fraction over here, and then I'll put version 2. And whether that's correct or not. And then I will also get rid of the accumulation using disjunction. Okay, so now our mission is we want to figure out if the version 2 for both problems are correct or not. Okay, you can see that we have no more accumulation, and what's going to happen over here? Okay, let's use the examples we have so far. Okay, so now let's think about what's going to happen. So result is going to be reassigned in every iteration. So let's now talk about the insight into this particular solution. What's going to be the last value for the result? The last value for the result will be whatever value you assign to it in the last iteration. When I is equal to IA.length minus 1, the last index. For example, in the case of IA5 over here, in the case of that, okay, what's going to be the result value? The result value is going to be whether or not the last elements in the array is a multiple of 5. In this case, 25 is indeed a multiple of 5. That means it will simply reassign the result to be true from the last iteration and then return true. That's absolutely incorrect. I will see that in just a moment to convince you. Okay, and also for this one here, is that correct or not? Similarly, you can see that over here we say that result is reassigned in every iteration, and then the final value for the result will be whatever we assign to it in the last iteration, in which case I is equal to IA.length minus 1. Okay, now let's look at the example over there. So now we have IA5B, this array over here. You can see that, so the result value is going to be whether the last element in the array is a multiple of 5, in which case it is not, right? Because 19 is not a multiple of 5. That means at position 4, we do have IA a position for multiple modulo 5 equals 0 will be false. That means the final result will be false. Okay, that will just return false. You can see it will in this case we actually return wrong result for both. Okay, you can see that. Okay, let me just double check with you, and then I'll tell you how to fix it. Okay, actually, how to fix it? The way to fix it will be either go back to version 1 where we do have accumulation, or I got another version for you. Okay, you should really learn all the versions. Okay, let's now run the tester over here. We want to see the running. So now let's go back to utility tester over here. We want to see all multiples of 5. I want to see for this one over here. Okay, IA5B. IA5B, we expect to see okay, let me just go back again. IA5, beg your pardon, IA5. What about IA5? IA5 is this array over here. We expect the result to be false because 19 is the witness of property violation. We expect to see false. Okay, but now there's a second last result. If you go to all multiples of 5, you will see that we expecting to see false, but it's actually true. So this is wrong. Okay, similarly, we also want to see for at least one multiple of 5. We want to see for the last one, IA5B. So now if you can see over here, IA5B over here, we are expecting to see true, because 25 is the witness of property satisfaction, so the result should be true. However, if you look at the result over here for at least one of multiple 5, you can see the last one over here is false, so that's also wrong. So the second version I show you over here is actually wrong. The easy way to see that is we got rid of the accumulation. And now that we got rid of the accumulation, so that means the result value over here is going to correspond to whatever only the last value of the array satisfy the property or not. And that's gonna be it. So now in the case of IA5, even if the witness already occurred before the last elements in the array, even if that's the case, but since we have no accumulation over here, you can see there's no accumulation over here, so it doesn't matter. So now as soon as you get to the next one, you get to index 4 over here, get to the next one, the previous result will just be wiped out. It's not it's not memorized anymore. Similarly, you can see that over here for this example over here, even though we already find out 25 being the property satisfaction witness, even though we did that, but if you see the code over here, there was also no accumulation effects, in which case as soon as we get to the last element, the next one, the previous result is going to be wiped out. It's only going to calculate if the last element is only going to calculate if the last element over here is a multiple of 5, in which case it'll give you the false result, which is wrong. Okay. Okay, hopefully you can see why the version 2 is wrong. Okay. Wrong because result only corresponds to if the last elements satisfies the property. Okay, version 2. And the same comments for both. Okay, version 2 is actually wrong. So now, how can I fix version 2 so that it's actually going to work again? One way to do it is just go back to version 1, where you do have the accumulation effects. Okay, another way to fix it is we want to say we don't want to do any accumulation, but we want to say as soon as we hit, for example, in the case of IA5, as soon as we hit a violation witness, as soon as we hit a violation witness, we will say the result should be false and we exit from the loop right away. We don't even bother to go for the rest of the array. Similarly, for the case of the at least one multiple of 5, we want to say we want as soon as we find out the property of satisfaction, as soon as we find out what it is, and then we're gonna say the result must be true, and then we exit from the loop right away without going any further for the rest of the array. Okay, that's the idea. So now how do we do that? Okay, so now let me just say version 3. Okay, version 3 over here. So version 2 is not correct, so I'm going to comment it out. Okay, also I'm going to comment it out. That's not correct, but I should know why. Of course, you don't want to program version 2 by yourself, but if I ask you something about version 2 in the exam, you should really know why it is wrong. Okay? So now, let's say we got version 3. Version 3. So now, as soon as a violation witness is found, exit and assign result to false and exit from the loop. Okay, similar comments for version 3 over here. I'll just write it up. Okay, over here. So now for version 3, for your at least one multiple of 5, as soon as a satisfaction witness is found, assign result to true and exit from the loop. Okay, I'll do that in just a moment. Okay, over here, I'm just going to put it here. Okay, I'll show you how to do it. Okay, so now, what can we do? So what we can do is, over here, I want to say as soon as the result becomes false, I have to, well, because if the current element I'm looking at is the violation witness, that means this expression over here will be false, and that will assign false to result. As soon as the result becomes false, I want to exit from the loop. That means I don't want to stay in the loop anymore. The trick to do is I can include the result value as part of the state condition. Okay, so I can say result %. So what does this mean? That means now I'm saying that for me to stay in this loop, it's only when, first of all, I have not found any violation witness, and also the index I'm looking at is not at the end of the array just yet, right? That's what it means. So now that means when can I exit from the loop? I can exit from the loop either when the result becomes false, which means the violation witness is already found, and or the I is already reaching to the maximum index of the array. Okay. So when to exit the loop? Either when result is false, or either way, right? Because if either side is actually false, then it will just it will make the overall conjunction false. Either when the result is false, or I reaches the maximum index of array. Okay, it's going to be a similar fix over here. So now over here I can say result or result and over here. Okay, so now that means this one here, let me just explain a little bit. This one is a little bit tricky. So now what I want to say is, as soon as let me just make okay, not here, sorry about that. Okay, that's version 3 I want to put over here. Okay, so now we want to say when to exit. Okay, I'll just make a similar comment. When to exit the loop. So now this is for the existential problem. So when should we exit the loop? In this case, we can say you can say either when I reaches the maximum index of array, or or result becomes true. And when result becomes true, that means the result when result becomes true, that means we already found the satisfaction witness. Okay, so when result becomes true, that means we want to say the following. We want to say it is not the case that result is true. And okay, so now this is a tricky bit. Okay, thinking this way. Let's say this example over here. Okay, IA5B. Let's say I'm now in this current iteration over here, this one over here. Let's say at index 3 is 25. 25 modulo 5 would be true. That means result will be assigned to true. Okay? As soon as result is assigned to true, what I will do is I'll go back to the loop header and check for the state condition again. Because result has just become true. So not true will be false. That means false and anything will just give me false to, that means I will exit from the loop. So this is the tricky bit. You gotta add a negation at the front in the case of the disjunction case. Okay, so that's maybe again study this carefully. So now both should work. Okay, so now let's test it and make sure we do have the result that we like. Okay, let's now just run the tester again and see. Oh, actually, you know what? I really want to comment this out as well. Okay, so we only got one version at a time. I'll only show you 3 versions over here. We still got version number 4, which is very similar to version number 3. You can look it up in the lecture notes. Okay, let's now just make sure version 3 also works. Okay, so version 3, I think the tricky bit is really over here. Okay, it's really over here. Okay, let's run it again. I'll make sure both works. Okay, so version 3 over here, first of all, we want to see for IA5, it should be false. Okay, so now all multiples of 5, IA5 is actually false. Very good. And now for at least one multiple of 5, IA5B, it should be true over here. Okay, that's also correct. Okay, so that means as soon as we actually hit the witness, we actually exit from the loop, either violation witness or the satisfaction witness. Okay, so now that's about how we can do it. Basically, now for all multiples of 5, now try to see beyond these 2 particular exercises. In the real test, I can give you any property to check. So this pattern is really similar. It's either or it's at least one. Okay, so the way we handle these 2, one is used by using a conjunction over here for accumulation, and the other one is by using disjunction for accumulation. And for one, the initial value should be true, and for the other one, the initial value should be false. Okay, let me just say one more thing. Okay, so now in the case of all multiples of 5, what about empty array? Okay, now if IA.length is actually 0, okay, let's see what's going to happen. If IA.length is actually 0, because the initial value for result is simply just true. Now in this case, because we know IA.length is actually 0, in that case, initial value of I is 0. 0 less than 0 will give you false. That means you cannot even enter the loop for the very first time. The result remains to be true. So that is correct. So that's why if you see the utilities tester over here, I have IA1 over here. You can see, what about the result for IA1? You will see that the result for IA1 will just be true, which is correct. And then what about result for IA1 for at least 1? In that case, that will be false. Why? Let me show you. If you go to utilities over here, now initial value for result is false. Let's say IA.length is actually 0 because I is empty, for example. And now, if you check the loop header over here, initial value for I is 0, and what about IA.length? IA.length will be 0 as well. So you have 0 less than 0, which will be false. So that means we exit from the loop right away. We don't even enter that for the first time. So that means result will just remain to be false as we initialize it and then return. Okay. So now, the coding itself for these 2 examples are not really difficult, but I would say for the purpose of your final exam and also for other written tests, you really want to make sure you understand the logic behind these 2 categories of problem for checking the properties, either for all or exist.